2026 will be the first year we're going to race this course. There's never been closed course multi-aircraft racing of this type.
What keeps you up at night when you design a race course like this? Okay, we held off on this because we were waiting for the official National Championship Air Races press release. We're working together with these guys, great bunch of people, bringing you the fastest motorsport in the world, and it's just about to get faster. So new for 2026, we are introducing the Jet Class Mach course, designed to deliver longer, faster, and more dynamic racing. Fans can look forward to the exciting addition, ladies and gentlemen, of two MiG-17 aircraft, adding even more excitement to the fastest class on the course. All right, ladies and gentlemen, today I'm joined with Matt Setti from the National Championship Air Races. Matt is one of the guys that most fans never notice, but every racer depends on him. Before the crowd sees speed, before the pilots strap into their aircraft, and before anybody gets to say, go race, somebody has to figure out where the race course goes, how the airspace works, how the pylons line up, how the G-forces line up, and how the FAA waiver gets supported. And how do you keep fast airplanes away from things that they should never hit? That's what we're talking about today. Matt serves as a director with the National Championship Air Races. He's been there a long time, 15 plus years. Started out as a volunteer. That's amazing how I tell people volunteer. So Matt is on the rah-rah board, and he's a race course designer. That's what we want to talk about today. He's the chair of the National Championship Air Racing Rules Committee, the National Championship Air Race Site Selection Committee. So he knows the inside, and he's the guy behind this really cool thing we're going to talk about. He's also a pilot, so that makes a difference, right? So he can see it from both ends, and he's got a background in Part 77 airspace, federal aviation engineering design standards, FAA survey and engineering standards, all the technical stuff that guys like me, I just go fly the airplane. We need smart people in the background doing this. And he owns Nevada Environmental Consulting in Reno, Nevada. And today I'd like to introduce to you Matt Setti. Matt, how you doing, man?
Doing great. Thanks, Dave. Appreciate you giving us a call and talking about this important topic.
Yeah, well, you know, everybody wants to go faster, right? It's never fast enough for the racers, and the fans love speed. And to take the fastest sport in motor racing, you did it, man. You just amped it up again. So what keeps you up at night when you design a race course like this? And you can explain, give us the background, right? I'm calling it a 600-mile-an-hour course, but that could be just me.
And it is. It's been termed now the Mach course. And our jet pilots and myself have got sat down over the last couple of years since we selected Roswell as our new location for NCAR. We've looked at this and said, it's possible to do it out there. We have enough room to run, you might call it. So we have a great big D, kind of a triangular D-shaped course running now. What that allows us to do is a 5G horizontal turn running 600 miles an hour. So that there's never been closed course multi-aircraft racing of this type. 2026 will be the first year we're going to race this course. Last year in 2025, our jets ran the traditional 525 miles an hour 5G course, which was the same design standards that had been in place for almost 20 years at Reno.
First of all, when everything left Reno, everybody cried the blues. And I went out to Roswell last year, and I want to say thank you publicly because you were one of the guys that got me out to the home pylon. And holy cow. Number one, the people in Roswell, fantastic. The location in Roswell, fantastic. You're going to do justice to this in this course design. You and your team couldn't have picked, I think, a better spot for air racing. There's nowhere else in the world you can do this.
Oh, hands down. I mean, there was a couple of sites that we could have raced at, but the complexity of putting on an air race with, 100 different ships in the air, up to 9 aircraft per heat. We need mass casualty events. We need crash fire rescue services. There's a huge economic demand, hotel rooms and all of that. And of course, that's the biggest challenge is where can I run 600 miles an hour and people will actually let me. And so we looked at initially 6 main airports that responded to their request for proposals and narrowed it down at the end to Roswell, New Mexico. And it's an old SAC base. It was one of the original bases for the Enola Gay. So it has some massive runways, 14,000 foot, 11,000 foot runways. It's an active alternate runway for a lot of the Air Force operations that are happening in that part of New Mexico. The neat part about what we're doing out here is there's a very great family that has the Brown family ranch out there. And the Holyfields have allowed air racing to occur over their ranch land. And that preserves the lands for long-term racing and kind of overcame one of the big hurdles that we had here at Reno, which was kind of the continuous encroachment or economic development of the airfield resources, other kind of drivers that pushed us out of Reno. So, one of our first opportunities here is to say, hey, if we're going to launch a new wave of racing, meaning moving that bar up to 600 miles an hour, we needed both land to do that, but we couldn't invest the resources to do that without longevity to that plan. So we plan on being at Roswell for a long time, and the community is happy to have us and are incredibly supportive. It takes a lot of volunteers. All of us on the board are volunteers. RARA actually has very few paid staff people, and they're full-time administrative and technical people. It's a massive volunteer organization, and it's done for the love of aviation and the love of racing.
I've said this before with my series last year. There are people that sit there and complain. And all we ask you to do is show up and buy tickets. But there's people that, instead of complaining, look at the impossibility ahead and step up. Everybody at RARA has stepped up and put on what was thought to be impossible last year. Impossible. Not all the classes were there, and people threw their hands in the air and said, impossible. This will never make it to 2026, right? And so those same people that said it'll never happen in 2025 are now saying, well, it's 2026. And now we have that 600 mile an hour mock course. Right. Is what everybody's been dreaming of. I know Rick Vandam for years, right? If you gave Rick a fast enough jet, he'd want to go supersonic around the race course. So any racer just wants to go out there, throttles up and go. But you've done something, and let's talk a little bit about the engineering and the design of putting together a course, because you said, 525 was the old course, 5G pull around this whole thing. Some of the pilots last year, first of all, every jet pilot I talked to, that's my class, every jet pilot loved it, loved that course from last year. And so we're saying, well, it's only 75 miles an hour quicker. You're going to talk about the engineering and the geometry of manhandling something like this behind me at 600 miles an hour, 50 feet off the ground. So right. Could you give us an overview?
Right. So because we have a lot of room out there, what we ended up doing is we oriented the start chute and the finish line directly in front of the crowd, moving parallel with the crowd. So we took all of those velocity vectors that were problematic at Reno, took those out of the equation. And what that allowed us to do is essentially go faster in closer proximity to viewing areas and maximizing our safety radiuses there. So what we do when we lay out a course is the course starts out at 50 feet AGL above the ground level. That's the top of the pylon. The pylons are a 50-foot telephone pole with an 8-foot culvert painted on the top of that. And the pylons, usually what we've done now is, because of the speeds we're moving, we have directional high-powered LEDs that are focused in on the approach angles the pilots are coming from so they can identify those quicker, make their course corrections. One of the golden rules in race course design is that you never want to lay out a course that leaves pilots wandering looking for the next pilot, because then you have people that are very aggressive pilots you don't want them wandering into each other when they're in, where the pilots call it, uncooperative formation flying. So that's a real critical thing. And you also want to be able to place pylons where it allows the good situational awareness as to what his approach angle to the next pylon is. We design a course around what's called the optimum race path. And that is a theoretical line that passes within about 25 feet of the outside of a pylon. It's a horizontal line that starts at 50 feet and goes up to 250 feet AGL. That's your vertical that you can be on that line going around the corner. From that line, we calculate that if something came off the aircraft came apart, whatever, lost control, it would go to 0 Gs. So at that point, the force of that aircraft would be tangent to the turn of that line. Just like if you were swinging a rock on a piece of twine and it broke, it would take off in the direction it is, like a sling. So then based on the altitude and the velocity, we calculate how far that's going to be in the air before it would hit the ground. And then with some safety factors, that's what we keep sterile. That line out there, several thousand feet sometimes out into the desert, outside the course, is our sterile line. So that entire width has to be managed by our rules committee, race and judges and field operations guys in order to keep spectators out of that area. That's one of our waiver requirements. So the challenge here is we want to be able to come out of a turn and pull tangent to the next turn, meaning we want that point that you roll back wings level to be in a logical place. And what happened at Reno is we had a whole bunch of little turns and you never really could unload the aircraft. So one of the points of discussion aerodynamically that we've engaged in, and I love it from an aviation perspective, is this is the first race course that we've had true straightaways that for any length of period, you could unload the aircraft into 0 Gs. And as a pilot, you know that when you reduce that wing loading, you're essentially getting some extra horsepower because of your reduction of its drag, correct? So this idea that you can pull out, and talking with Jerry Kirby and some of the other pilots that are out there, that ability to pull out on that back stretch and gain that increase in speed while putting the nose down and decreasing your G loads is one of the finesse moves that these really skilled pilots have out. And that also plays different. We'll see it this year with the unlimited races. So a big wide Bearcat wing is going to perform differently in those straightaways than a laminar P-51 airfoil.
Absolutely. It's going to bleed energy differently. It's
correct.
We always talk about STEM at air shows, right? Look at the math behind what you're doing, right? I mean, wouldn't that be cool to kind of show young people, this is the reality of math, you know, oh, I don't need to use math. Well, here you go. Everything you just explained is mathematics and fairly, I mean, it's not that it's simple math, but it's something that can be readily calculated. I think that's what a lot of people think. I just need room to run and I can go run my jet as fast as I want. And you've got so many elements built in, not to mention, like you had said, scatter distance, you know, God forbid we hit each other or something else. But what other elements besides the mathematics now, when you're devising that course, are there separate air regulations, FAA regulations, air show regulations that you need to follow?
Sure. So there's quite a few. There's a minimum distance that you could be to a primary spectator area, you know, and that's usually 500 feet, depending on what you're doing there. And so we've been able to push that right up to that safety radius being just out from 500 feet. And the nice part is all of the direction of energy is parallel to and away from the crowd. So a lot of those concerns that ultimately limited our ability to go faster at Reno, because as you go faster, those safety radiuses increased. You couldn't make that turn 8 at Reno and keep pushing that into the crowd, even after the major redesigns after 2011. The FAA 8900, so like everything in aviation, right, we go to the Bible, right? And so 8900.1 lays out the equations that we use. So it's not like I came up with the math. I'm simply just plugging our numbers into the FAA's equations. And those equations assume a couple things. They assume that we're racing with no wind drag. So in that sense, it's conservative, right? So we're not reducing that distance as a function of wind drag. And that's why when we've had accidents in the past, we survey all of the debris fields and we validate that they stay on our race courses. So that's part of the work we've done with NTSB in the past to demonstrate that the regulations that we're using to estimate the safety boundaries are valid. A couple of the other elements that we come into play here is the different race aircraft can be a little bit different. This year, because we have the room, we've actually increased for some classes the ceiling to 350 feet. Traditionally, we've allowed going above 250 and coming back into the race if you were going for safety purposes, getting out of, some prop wash or something like that. We used to have large debates that would end up in the rules committee about pilots that would sit there at 400 feet and make big ovals. And there's, within the race fan community, there's kind of a lot of jokes about that, right? And so that's part of where we're going with this bigger element here is the telemetry side. You mentioned STEM. We've talked with the STEM guys quite a bit because normal GPSs on your aircraft don't work in racing, right? We need high repetition rate positions. Otherwise, you're getting one position every 800 feet or something. So those types of advancements are coming into the racing, but we're using them as guidance to train our traditional eyes, right? Because as you know from the pilot, you still have, and especially in racing, you don't rely on ADS-B data in racing, right? So for awareness. So what we really want is our ground crews out here. It's a great site for telemetry. So a lot of times our pilots have their eyes outside the aircraft flying, aviating, right? And their crews can be real-time telemetrying on their engine systems and things like that. And so the advancement that racing has always given aviation is still going to be there. And as we have larger, faster places to race, new forms of composite aircraft coming on, it's not only the jets that are going to be going faster. We're going to have sports unlimiteds, which super sports right now have a 425 mile an hour course. That's moving if you're flying a Lancer or Pulsar or something like that, right? It's sort of a rising tide lifts all boats in this case, as far as the technology goes.
You're about 800, just under 900 feet per second at 600 miles an hour. Is that about right? I mean,
that's when those power lines look like picket fences, right? So.
Yeah, I mean, that's amazingly quick. It's the draw, right? So I like to touch the third wire all the time. Everybody was upset last year about unlimiteds. Well, unlimiteds are back in 2026. But here's the other side of that. As I said, jets are kind of where things are moving forward from an operational ability. At some point, these old World War II planes, we should be blessed that we can see them fly, right? I mean, so
it's true, right?
Yeah. So I always tell people whenever there's an air show or aviation event that has any of these things, show up and support them, because that's what brings these airplanes out. But the 600 mile an hour course, let me ask instead of thinking, it's just jets flying the 600 mile an hour course this year?
Correct. Yeah.
Okay. We've all heard this thing. Well, the jets are this and the jets are that. They're not the World War II airplanes. Okay. Different airplane, right? A J3.
Right.
Yeah. So what? They're all different. I fly an Iskra at air shows, not because I picked the airplane for any other reason that we fly at a carnival, which is an air show. This is an air race. And so going faster is cool. And it's one more thing that, man, I'll tell you what, if you have a chance to buy tickets and get to Roswell and sleep in a tent, for God's sakes, this is going to be the first time that anybody's racing on this course. What keeps you up at night when you look at this new course, new things? Anything new is going to have growing pains, right? I mean, we all know that. What keeps you up? What things do you look at as, just like any pilot, what should I be checking? What are my outs? What are my backup plans?
Well, the nice part about this is one of the criteria that was really a tipping point is you're going to break your airplane, but you could set an airplane down almost anywhere out there. We are right now building an emergency runway, and this is generally for the smaller racers and the unlimiteds. The jets carry enough energy, even out on the outer course. They carry enough energy that something goes wrong, they can make it back to the primary runways. The smaller aircraft racing on some of the larger courses there may not be able to make it all the way back. They just don't have enough energy, depending on what their airspeed is when something goes wrong. So we did put a 6,000 foot by 100 foot emergency runway out there, compacted dirt, where you'll be able to tow back in from there. So if you got a problem with your engine, you can set it down. So those are the safety factors that we're building into this new venue over time. We have a world-class crash fire rescue operation out there. And really overall, visibility, prevailing wind issues, all of these other things that affect how things respond when things go wrong have really stepped up over what we were able to even provide at Reno. Reno was always seen as an exciting but also a safe place to race,
Yeah.
But it was a challenging place. We don't have the couple 100 foot of vertical difference on this course. So the nice part is you can see the aircraft all the way around the course. That's a real thrill. City of Roswell completed a new, I think, 9,000 seat grandstand, and they fixed a lot of the drainage issues and the pit issues that we had in year one. So tremendous amount of work's been done out there. We're going to have a B-52 on site. I think there's 16, as I heard rumors of unlimiteds. Let's see, if the Ukrainians keep it up, we might have a yard sale of MiGs coming up. You'll have to get, we got a couple of MiGs that you'll see out there this year, and that'll be one of the first times you see MiGs actively racing.
The first time I saw a MiG on the race course, and you were there, I'm sure, was after the race was over. We stayed in the grandstands, and you had the MiG-17s out there going around the race course. What a thrill that was, and hardly anybody stayed back to watch that. You're going to see it, right? I mean, if I owned a MiG-17, I would love to bring it out.
Yeah, I talked to the guys just this week over in Ogden, Utah, with the Vampires and Vipers and Vampires and those. And so whether everybody makes it this year or not, I think there's enough jets that are in the civilian market that guys that are willing to turn dollars into noise are willing to come out and race them. So it's a big thrill. And I think from a standpoint of the jets really carrying the flag for the national championship air races through this transition, it's been a real honor to work with an incredibly dynamic and talented group of pilots that race out there.
No, it is. And I know from the people I've talked to, they're chomping at the bit. So the racers are chomping at the bit. The people, the fans are going to get a great show. Maybe discuss just a little bit about G-loading and turn radius and the speed and kind of what happens as you go past, from 400 miles an hour to 600 miles an hour. Is it a linear progression, or are there some exponential types of things that we need to look at from a pilot standpoint and a design standpoint?
Well, we don't, from a laying out the course standpoint, we kind of set the geometry of the course, but we don't set the rate of loading, right? And that's what means everything as far as what that ride's going to be like, right? Most guys can handle a 5G load if it's coming on, in a certain amount of time. One of the real concerns that we had, and we worked with our flight surgeons and we worked with Jeff Turney and a bunch of Rick and the other guys in the jet class, is we wanted to make sure that we could space that long straightaway in the back. We could space these out far enough that you pull into a 4.5 or 5G turn coming around there, or even lower than that if you're not up to speed. And then you had time to recover. Because remember, in the race aircraft community, these guys aren't running G suits. I don't believe any of the aircraft typically have a G suit, and they usually take the back seat out, lighten things up. And so they're all pretty well trained pilots and fit and that, but they have rigorous physical examinations. We have a flight surgeon that works with them, and we do a G-load briefing as a part of our regular annual trainings. But part of that also comes down to how we space those corners out from each other, right? We have to, if at a given speed, you have to have a certain number of seconds to recover from the onset of a G-load in order to be at optimum conditions before going into the next one. And that's one of the things that you couldn't do if we didn't have these big distances on these courses. So it's an 11-mile course, a little over 11 miles around that big course. Yeah. 10.2 around the unlimited jet 525 course. And that's what the old course at Reno used to be before it was reduced to 8. We're kind of trying to reclaim some of those little longer lap distances, but you're moving faster. So you see the airplane the same amount of time.
The guys who are out there flying and can time their own set of Gs and relate that to the energy bleed as associated with that G load, you'll have more of a race. I mean, a lot of thing at Reno in jets, once you rolled in off the guide pylon there, there was not a lot of smash difference in the airplanes. We all put the throttles at 106% and leave them there. And you're still going to leave the power up on this race course. But I think what you just mentioned is key, that G onset. How do you play that? How do you play pitching over for some extra speed? You've got that straightaway to do some strategy. So Now we got a race. We got some cool racing, especially with the personalities that I know for a fact are lining up for that race course. I mean, with those personalities and those airplanes and your course, that's entertainment. Yeah, there's ego, but we're here to entertain the fans and put on a show because it's not an air show. There is an air show component, and that's great.
We have the Thunderbirds this year. It's quite a show,
It is. You guys have got a packed schedule with all the aircraft coming. So we don't have terrain issues like we had. There's going to be wind. That's going to affect everything. Last year we had a little bit of rain, big deal. But was there any major challenge? So when you put this idea, the idea is easy to have, right? We can all have great ideas. But now when you went to implement this, did you run into any certain major roadblocks that you can talk about that made you kind of shrug your shoulders and go, man, this is going to be harder than I thought? Or was it smoother than you thought? I'm assuming.
Well, I think there was a component of this is baby steps, right? The course that was run last year, the north and the south turns were already set up around a geometry of 600 at 5Gs. So the radius of those north and souths were already with the idea that the 600-mile-an-hour course was coming. And it was this middle course, the dogleg in the back, was the one that was set at the minimum turn radius equal to 525 and 5Gs, which is very, very close to the Unlimited's 500 at 4Gs. Those are almost the same radius. So what I do is I take the larger of the two for safety purposes, and we just run them at the same geometry. So it's not exactly... it doesn't go down to the foot on the radius turn. But that allowed us to be able to come out there and have the pilots take a look at a turn like that. So they know what they're getting into this year as far as that turn goes. One of the requirements that we have is that in racing under the FAR 8900, you can't take more than 45 degrees of turn without putting a pylon there. And so that's why when you go down, if you're going to turn that far, you're running 3 pylons around there. So we had kind of built into the progression of the development of the course that we were going to add these 3 pylons. The numbering actually is the same as the other course because the way it sets up, it just takes that corner and moves it out. I think it'll be pretty exciting for people to come in there and be able to see that. And the neat part is to be able to come in and show a traditional echelon turn like we did for years at Reno, but this time it's right in front of the crowd across the pylon. So we have over 1,100 feet wide, which we never had at Reno, that we can put wing on wing with an entire race class and roll them into turn 1. That's a real thrill to see as well.
It was a totally different vantage point, after a while. You're always looking to your right, watching them come over on the jets anyway. Jets always came in over my right shoulder, but now they're right down and you can see the pilots.
Yeah.
You never saw pilot. Yeah, you never saw pilots under the old way, but now I think that's kind of cool, right? Coming past and that first line abreast as they come across home pylon is exciting. And the finish, because you're wound up. You're not coming out of a high G turn aimed right at the grandstands. So safety for the people showing up, number one, first and foremost, safety for everybody. And the pilots appreciate the course because everyone I talked to, I didn't hear one bad comment on the course. So outstanding job. Every year it's a change. It's new. I don't want to beat it up to death, but where else are you going to see this? In a flash, these type of events go away without the spectators supporting them. Right. So, right, you spent 15 years as a volunteer, and so
well, still am. All of us that love this game, we're all volunteers, other than the administrative staff. So that's what makes this neat is that people invest their time. I mean, I'm slow making my maps, and everybody else gets frustrated. But we have a tremendous team of volunteers, and they all come from really interesting aviation related backgrounds. And most of us are pilots. That helps because it allows us to maintain that thread of safety as the ultimate goal here. And and it works. I think we had one Mayday last year, and it was an engine problem that landed without incident. I think that was the lowest we've ever had. So we're really looking forward to a great race this year, and we're welcoming back the sport planes. I know we have a couple of heats of sports planes. We have a couple of heats of Unlimiteds. And then, of course, the biplanes, they're getting faster and faster. I mean, we have biplanes now that are going to be running almost 300 miles an hour pretty soon. They have a course that's rated at 275 miles an hour, 3Gs, and 250 in the F1s. So think about a Cessna 200 engine doing 250 miles an hour in
That's
an
amazing.
O200 powered engine.
That's amazing.
It's amazing. It is. It really FADAC controlled, O200.
Where does air racing go forward? Do you foresee any new classes or new technology? It's easy to look backwards, but looking ahead as
there is. We'll see some new technologies as it relates to changes in aviation fuel, general aviation fuel, how we build motors to with handle, unleaded fuels and other stuff like that. I don't know where it is on the horizon, but I'm sure that in the next couple of years we'll see an electric class or an electric turbofan class. There's a lot of PC-12 pilots that are itching to get out there and fly their PC-12s around.
There you go. Well, do you remember back when there was the Rocket Racing League that was going to start up? They were like a long easy that had a rocket motor that I think you turned on and off, right? It was not even a throttle. Yeah.
I'll get calls from guys that have pulse jet experimentals.
That's unbelievable. Unbelievable.
So we appreciate your attention to the races. I think that, like we said earlier, one of the great things about your podcast is its sort of continuous highlighting of the safety aspects of air racing, or of aviation. That's a shared paradigm with what we do out there. So we'd love to have you out. I look forward to throwing you in the truck and driving around and getting some good shots this year from the race course.
I'm coming. I got the hotel room already resolved. I bought it last year before I left. I said, I'm coming back. This is outstanding. And the city of Roswell and the people of Roswell, when you walk around that town, they want us there.
Oh, yeah.
It's...
Yeah. They really want their UFO class, and I'm not sure how to design that if I don't really have traditional aerodynamics to limit my designs.
Well, if you're into quantum physics, we can do all kinds of string theory and other stuff. Maybe it'll be the first multi-dimensional race course. There you go.
Right, those 100G loads.
Yes. Right on. Well, Matt, hey, I really appreciate it. I know you're busy. I know you got a business to run, and we've been trying to get together, and I just want to thank you. Let's hook back again if anything changes or if you got anything else. And I want to thank you again for getting me out to the home pylon after all these years. To stand out there last year was a thrill. So thanks for your hard work. Thank the rest of your team as well.
You bet. We appreciate it. Thanks, Dave.
This is Dave Costa. I am the Renegade Aviator. See ya.